We're going to give you a quick lab to do in the couple weeks before your next class. For this lab you'll need a dynamics track and a couple of stops. I placed one at each end. You can also use the stops that slide onto the trackaways. You'll want two dynamics carts, one with a plunger and the other without. And you'll want some masses that are preferably real close to the mass of the carts. They do not have to be these kinds of masses. These carts come with some rectangular masses that can be used. Place a piece of Velcro on one end of each cart and also on each stop, so that when the carts go and strike the end, the Velcro catches them and there won't be any bouncing. We want the carts to be a nice distance apart. I made mine 90 centimeters apart. And the purpose of this lab is to get the relationship between the ratios of the masses that are moving apart and the ratios of the magnitude of the velocities. So we're going to call one cart mass A and one cart mass B, and then we'll do the ratio of the velocity of A to the velocity of B. We don't really care exactly what the masses are. We're just going to call this one mass M and this one mass M. So I'm going to call this cart A, cart B, both of mass M. Now, to get the velocities, we're going to make sure that the carts hit the ends in the same amount of time. If they do that, we know that the distance that they traveled is directly proportional to the velocities. I'm going to make a wild guess that if the masses are the same, to get them to travel the same time, I need to have the same distance. So let's see if that hypothesis is correct. So I'm going to give this a tap. I only heard one thunk, so they did hit in the same amount of time. So in this case, the ratio of the masses, mass A to mass B, will be 1, and the ratio of the velocities will also be 1. Now we put the plunger in again and make one cart have a mass of 2 times M. I'm going to put them in the middle again, do a trial. Well, obviously they didn't hit in the same amount of time, so I have to find that location. One other tip is to have the mass up against the lip of the cart so that it can't slide when the cart is propelled. So let's try another location. And that time I only heard one thunk. So I would record the distance that each cart moved, and the ratios of the distances would also be the ratios of the magnitude of the velocity. What is that distance? I'm not going to tell you. You're going to have to find out on your own. For the successive trials, we'd like you to have mass M, and this one be 3M, mass M, and have this one be 4M, and have this one be 2M by adding 500 grams if you have 500 gram carts, and this one would be 3M. If you want to do more than that, it's entirely up to you.